I'm going to solve a series of example problems here that are finding the volume of a solid of revolution using the disk or washer method. And what I'm going to do is I'm going to take the same region and rotate it about a bunch of different lines and see how we can set up and find the volume in those cases. So we're going to take this solid here, so y equals 2 times the square root of x and y equals x in the first quadrant. The way, of course, that's going to look, y equals x is pretty easy, right? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so on. Right? So that's going to be y equals x. Y equals 2 times the square root of x. Well, if I plug in 0 for x, I'm going to get 0 for y. If I plug in 1 for x, 2 times the square root of 1 is 2. And if I plug in 4 for x, 2 times the square root of 4, 2 times 2 is 4. So we get that here. Now it looks like then, of course, these intersect at 0, 0, and 4, 4. Sometimes that's not totally obvious. The way I could set this, find that intersection is I could just set the y coordinates equal to each other so that I would get 2 times the square root of x is equal to x. And then I could just square both sides of the equation. So 2 squared is 4. Square root of x times square root of x is just x. X times x is just x squared. So we've got x squared minus 4x equals 0. We can factor out an x. And that tells me then that x is equal to 0 or x is equal to 4. To find the y coordinate, I could go back to either one of these equations. 2 times the square root of x or just y equals x. Right? So if x is 0, y is 0. If x is 4, y is 4. And we do have those points of intersection that we thought. We've got the point 0, 0. Down here. And we've got the point 4, 4 up here. Okay. So I'm going to rotate this then about the x-axis, it says first, so that's going this way. If I'm going to rotate about the x-axis and I want to get a disk or a washer, I'm going to need my rectangle to be perpendicular to that. So since I'm going around a horizontal line, my rectangle is going to have to be perpendicular. It's going to look something like this. What is this solid going to look like? Well, I could sort of imagine, drawing in the symmetry here. And then, this would make a sort of a bowl shape around that. And then there'd be but it would be hollowed out in the inside, right? So it's sort of a bowl shape on the outside. It would be like a cone hollowed out on the inside. That would be this solid that I'm getting. I'm going to get rid of that so it doesn't obscure what I'm doing here. Okay. When I rotate this rectangle about that axis, it's going to give me a washer. I'm going to get that kind of thing. And so for that washer, I'm going to have to find the area by taking the area of the outer circle and subtracting the area of the inner circle. So again, I'm going to sort of get rid of that because it's obscuring what I want to do there. So what I'm going to need then that's going to be my inner radius. I did that too big, I think. We'll go over to here. That's going to be my inner radius, and if I come up here, that's going to be my outer radius. Okay, so that's the distance from the bottom of the rectangle in this case to the axis of rotation. Right? That distance is my inner radius, and from the top of the rectangle down here is my outer radius. Now, how do I find those? Well, what kind of a rectangle is this? It's a vertical rectangle. So I have to subtract the y-coordinate on the top minus the y-coordinate on the bottom. And so the y-coordinate on the top here, that's on the square root graph. So this top is y equals 2 square root of x. The y-coordinate on the bottom is on the line, so that's y equals x. So what I've got here, my outer radius is the distance from the top to the axis of symmetry. The other thing, of course, what I've got here, this axis of symmetry, or the axis of rotation, not symmetry, is the horizontal line y equals 0. So my outer radius is from the y-coordinate at the top of the rectangle to the y-coordinate of the axis, which is 0. So my outer radius is 2 times the square root of x minus 0, or that would just be 2 times the square root of x. My inner radius is then from the line, so that would be x minus 0, or just x. And the volume of my washer is going to be pi times the outer radius squared minus the inner radius squared. So I'm going to get 2 times the square root of x squared minus just x squared. So 2 squared is 4, so I get 4x minus x squared. So my overall volume then, I'm going to integrate. I can pull out the pi. My little thickness here is going to be a delta x, right? My rectangle, the width of the rectangle is delta x. So this is going to be x limits. So for this region, I'm starting over here on the left at x equals 0. I'm ending up at the right at x equals 4. So x equals 0 to 4. And then I'm going to do this 4x minus x squared dx. Okay. So I take the antiderivative. I increase the exponent by 1 and divide by the new power. So I've got this pi going along for the ride. I plug in 4 over 2 is 2 times 4 squared minus 4 cubed over 3. And then when I plug in 0, I get 0 squared, well that's 0, I get 0 cubed, that's 0. This whole thing just becomes 0. Just a caution, just be careful when you're plugging in 0, think about what happens when you plug it in. Don't just assume it's always 0, although it's going to be in a bunch of the stuff we're going to be doing here in these examples. But it can be a danger that you just assume it's 0 all the time. You want to think about what happens if you plug 0 in. So what do I get here? 2 times 4 squared. 2 times 16 is 32. I get 64 over 3. Minus 0 I don't have to worry about. So 32 over 1, if I multiply top and bottom by 3, I'll get 96 over 3 minus 64 over 3. So that ends up being 32 over 3, and I can just put the pi in the top, and that would be the volume that we would get if we rotate this about the x-axis. Now, if I look at this, and I take the same situation, the same region, so I'm still going to have this line y equals x, and I'm going to still have this 2 2 square root of x graph. It's going to come up here and again go through 4, 4. The difference here is that I'm rotating now about the y-axis. So I want my rectangles to be perpendicular to that. That means my rectangles are going to have to look like this. And there's going to be a little delta y instead of delta x. So my integral is going to have to be in terms of y instead of x here. I still have this point down here, 0, 0. And I still have this point up here, which is 4, 4. And we would find all that the same way that we did earlier. I'm not going to reinvent the wheel here every time. The difference, of course, now is if I rotate this, I'm rotating it this way. And so if I would connect this, we would have a washer like that. So I'm still going to have to think about an outer radius and an inner radius and subtract those. Let me clear up stuff here a little bit. So my outer radius and inner radius are going to have to be found like this. That would be my inner radius. And that would be my outer radius. And of course, that rectangle now is in the x direction, not in the y direction. So to find the length of this rectangle, I'm going to have to subtract x coordinates. Instead of y coordinates. So the line is easy, right? The line right here is the line y equals x. But if y is equal to x, then x is equal to y, right? And so that's this endpoint of the rectangle is on the line. So that's x equals y. This other one, well, we have y equals 2 square root of x. We're going to have to solve this equation for x. So if I square both sides, we would get y squared equals 4. Square root of x times square root of x is x. So I end up getting that x is equal to y squared over 4. Okay. So to find this outer radius and the inner radius, again, this is the y-axis has equation x equals 0. To find my outer radius, I'm going from this edge of the rectangle that's on the line all the way to this axis here. So the x-coordinate on this end of the rectangle is y. The x-coordinate of the axis is 0. So my outer radius is just going to be y minus 0, which is just y. My inner radius, on the other hand, is from this left end of the rectangle to the axis. So that has an x-coordinate of y squared over 4 and then an x-coordinate of 0. So I'm going to get y squared over 4 minus 0, which would just be y squared over 4. So then the volume of my washer is pi times the outer radius squared minus the inner radius squared. So I'm going to get the outer radius is y, the inner radius is y squared over 4, and then all that has to be squared, right? So that's going to be pi, and I'm going to get y squared minus y to the 4th over 16. So for my overall volume, I'm going to be integrating, but now I'm integrating with respect to y. Now for this particular region, it doesn't really matter if I'm integrating with x or y because the numbers are the same, but that's not always going to be the case. In this case, I would look at the y coordinates. The y coordinate here is 0, the y coordinate here is 4. So it's going to be from 0 to 4. Oh, I didn't take out my pi. That would go out in front. I'm going to get y squared minus y to the 4th over 16 dy. So that's going to be pi. I'm going to get y to the 3rd over 3, y to the 5th over 5. So there's already a 16 in the bottom. If I put another 5 in the bottom, 5 times 16 is 80. So that's what would be in the bottom, and that's going to be from 0 to 4. So I plug in 4 cubed over 3 minus 4 to the 5th over 80. And then I plug in 0. 0 cubed over 3 is 0. 0 to the 5th over 80 is 0. So I don't really have to worry about that lower limit. 4 cubed is 64. 4 to the 5th is 1024. You can use your calculator, of course. 1024 over 80. It turns out I can divide both top and bottom by 16. So 1024 divided by 16 is 64. And 80 divided by, 80 divided by 16 is 5. I'm going to get a common denominator of 15. So I'm going to multiply by 5 and 5 and 3 and 3. So 64 times 5 is 320. 64 times 3 is 192. So if I subtract, I get 128 over 15, and I'll just stick the pi up there, and that would be the volume. Notice it's not the same volume that we got in the last example, so it makes a difference, you know, which axis we're rotating around. Okay, this next one, same region, but now we're going to rotate about the line y equals -1. So I still have my line y equals x, and I still have this same square root graph. So I've got these same points of intersection. We would find that just, you know, like I did on the first problem of this set. In this case, we're rotating about the line y equals -1. That's this line down here. Okay. And so that's a horizontal line, so my rectangle is going to have to be vertical. And that means I'm going to have a little delta x. So my integral is going to be with respect to x. I'm also then going to have to look for my outer and inner radius. This would be my inner radius, right? That's the closest distance from the rectangle to the axis. Whereas the top of the rectangle here, then, that's the farthest distance. That would be my outer radius. And to find that, well, those distances are vertical distances. The inner radius is going up, the outer radius is going up, so I'm going to have to subtract y coordinates. So what's the y coordinate here? Well, the y coordinate on the bottom, that's along the line, so the y coordinate is just x. And what's the y coordinate here? Well, that's on the curve. That's y equals 2 square root of x. So, what's my outer radius? We have to be careful here. The outer radius is this distance here. It's not just 2 square root of x. That's the distance above the x-axis. Here we're having to go from -1. We take the y-coordinate at the top, that's 2 square root of x, and we subtract the y-coordinate at the bottom, which is -1. So we get 2 square root of x minus -1. So the outer radius in this case is 2 times the square root of x plus 1. The inner radius, we do the same sort of thing. We take the y-coordinate at the bottom of the rectangle and we subtract the y-coordinate for the axis of rotation. So we get x minus -1. So my washer then, when I rotate this, I'm getting a washer. It's going to be the outer radius squared minus the inner radius squared. So the outer radius is 2 square root of x plus 1 squared. The inner radius is x plus 1 squared. So 2 square root of x plus 1 times 2 square root of x plus 1 minus x plus 1 times x plus 1. So 2 square root of x times 2 square root of x is 4x. We get 2 square root of x times 1 and 2 square root of x times 1. That gives me 4 square root of x. 1 times 1 is 1. Minus, here I'm going to get x times x. 1x and 1x is 2x plus 1. So I get 4x plus 4 squared of x plus 1 minus x squared minus 2x minus 1. So I get negative x squared plus 2x plus 4 square root of x. Okay, so a lot of work there just getting that stuff together, right? Okay, so what's my overall volume? Well, these rectangles are vertical. There's a little delta x, so I need x limits of integration. X is going to go from 0 to 4. Oh, we've got the pi, I should have brought out. We've got this negative x squared plus 2x, and then I'm going to write this, instead of square root of x, I'm going to say x to the 1/2. So I take out the pi, and now I take the antiderivative. So negative x squared becomes x cubed, and I have to divide by 3. I'm going to get 2x squared and divide by 2. And then I'm going to get 4x. If I add 1, that's adding 2, so that becomes 3 halves. And then I have to divide by 3 halves. And that's going to be from 0 to 4. So negative x to the third over 3 plus x squared. When I divide by 3 halves, that's the same thing as multiplying by 2/3. So 4 times 2 is 8. So I'm going to get 8x to the 3 halves all over 3. Let me do this just a little bit lower. I'm going to get So we get 8 x to the 3 halves over 3, evaluated from 0 to 4. So I plug in 4, negative 4 cubed over 3, plus 4 squared, plus 8 times 4 to the 3 halves all over 3, minus 0 cubed over 3 is 0, 0 squared is 0, 0 to any power is 0, so that all just ends up being 0 when I plug 0 in there. So I get negative 64 over 3 plus 16. Remember how the 3 halves power works. This 2 in the bottom means I'm going to take the square root of 4, and then I'm going to take the third power. So the square root of 4 is 2, 2 to the third is 8. So that's going to be 8 times 8 over 3. So that's 64 over 3, which is exactly the negative thing we had there. So those fractions drop out, and I just get a nice volume of 16 pi. So I had a little more work in figuring out my outer and inner radii here. All right. So here I've got the same region. I'm keeping it simple so we can really concentrate on how this works when I just rotate it differently. So there's my line. Here's my square root graph. But now what I'm doing, and I still got these same points. Zero, 0, and 4, 4. Now I'm rotating about the line y equals 6. So I'm rotating about that line. So that's horizontal. So I want my rectangles to be perpendicular to that. So my rectangle will have to be vertical. What I need then is to figure out, when I rotate this, there's a gap between the rectangle and the line, so it's going to be a washer. So I'm going to need an outer radius and an inner radius. The inner radius is going to be from the top of the rectangle up here. The outer radius then is going to be actually from the bottom. That's the farther distance to this axis of rotation. And of course, those are vertical distances, so I'm going to have to subtract y coordinates. So the top of this rectangle is on the curve, so that's y equals 2 square root of x. And the bottom of the rectangle is along the line, so that's y equals x. So my outer radius is this distance here. That's a y distance, a vertical distance, so I'm going to have to subtract y coordinates. I always take the top minus the bottom. What's the y coordinate up here? Well, that's y equals 6. What's the y coordinate down here? It's just x. So my outer radius is going to be 6 minus x. My inner radius then is this distance right here. The top is a y coordinate of 6. The bottom is the y coordinate of 2 square root of x. Okay, and so what I'm going to have to do with that is now find the volume of the washer. So that's going to be the outer radius squared minus the inner radius squared with the pi in front. So outer is 6 minus x, inner 6 minus 2 square root of x, so 6 minus x times 6 minus x, 6 minus 2 square root of x, 6 minus 2 square root of x. So 6 times 6 is 36. I get negative 6x and negative 6x, so that's negative 12x plus x squared minus 6 times 6 is 36. 6 times negative 2x, that's negative 12. 2 square root of x, negative 12 square root of x, and another negative 12 square root of x. So that's negative 24 square root of x. Negative 2 times negative 2 is positive 4. Square root of x times square root of x is x. So we get pi 36 minus 12x plus x squared minus 36 plus 24 square root of x minus 4x. Running out of room. So I've got an x squared. I've got a negative 12x and a negative 4x, so that's going to be a negative 16x. I've got a plus 24 square root of x, and then my 36's cancel out. So my overall volume, I didn't write this here, but that's a little delta x, right? That's a little delta x, so it's in terms of x. So pi x is going from 0 to 4. And I'm going to get this x squared minus 16x plus 24x to the 1/2 dx. All right, so let's take the antiderivatives. I'm going to get x to the third over 3. I'm going to get 16x squared over 2. I'm going to get 24x to the 3/2 divided by 3/2. So that'll be x to the third over 3 minus 8x squared. 24 divided by 3/2 would be 24 times 2/3, so 48 over 3. This ends up being 16x to the 3/2. You can work on that on the side if you need to. All right, make sure you see where that's coming from as I go from 0 to 4. So now I'm going to plug in the 4 and the 0. So 4 to the third over 3 minus 8 times 4 squared plus 16 times 4 to the 3/2. When I plug in 0, 0 cubed over 3 is 0. 8 times 0 squared is 0. 0 to any power is 0. So a whole lot of nothing going on there. 64 over 3. 8 times 16 is minus 128. 4 to the 3/2, I would take the square root of 4 and get 2. 2 times 3 is 8. All right, back. So 64 over 3 minus 128 plus 128. So I just get 64 pi over 3. Okay, hope you're getting the hang of this, how these radii go. Let's look at another one. This is the last one of this type. So, same region. We've got the line y equals x, and we've got this square root, we still have these points, 0, 0, and 4, 4. But now we're going to rotate about the line x equals 5. Ooh, let me get rid of that 4, 4. I'm not going to label it. I think it's going to make it too messy. We know where that is by now. So we're rotating around this line x equals 5. Since that's a vertical line, my rectangles are going to have to be perpendicular. So I'm going to go this way. So I'm going to have a little delta y, right? Where when I rotate this rectangle around that line, it is going to make a washer, right? And when that goes around, there's a gap here. So I'm going to need an outer radius and an inner radius. The inner radius is going to be here, and the outer radius is going to be here. Those are horizontal distances, right? These radii are moving horizontally. So to find a horizontal distance, I have to take and subtract x coordinates. You have to take the larger minus the smaller. So I'm going to have to take the right x coordinate minus the left x coordinate. But what that means here then is I'm going to have to know what's this x coordinate and what's this x coordinate. Well, this x-coordinate is the right side of the rectangle. That's along the straight line. The x-coordinate there is equal to just y. This x-coordinate is the left side of the rectangle. That's on the curve. The curve has the equation y equals 2 square root of x. To find the x-coordinate, I need to solve this equation for x. So we get x equals y squared over 4. So my outer radius is this distance. It's an x distance. I take the right minus the left. So the right x coordinate is 5. The left x coordinate is y squared over 4. So I get 5 minus y squared over 4. For my inner radius, that's this distance. My right x coordinate is 5. My left x coordinate is y. And so for my washer, when we look at that, I'm going to get pi times the outer radius squared minus the inner radius squared. So the outer radius, 5 minus y squared over 4, all of that squared. And the inner, just 5 minus y squared. So 5 minus y squared over 4 times 5 minus y squared over 4, and then I get 5 minus y times 5 minus y. So 5 times 5 is 25. 5 times negative y squared over 4, so that's negative 5y squared over 4, and I get that twice. So I get negative 10 y squared over 4. and then I get negative y squared over 4 times negative y squared over 4, that's positive y to the 4th over 16. Here, 5 times 5 is 25, minus 10y plus y squared. So we get 25 minus 5y squared over 2 plus y to the 4th over 16 minus 25 plus 10y minus y squared. So the 25s cancel out. I get y to the 4th over 16. We get minus 5y squared over 2. And then we've got this other minus y squared. I could write that as minus 2y squared over 2. And what else? I still have that 10y plus 10y. So I get pi times y to the 4th over 16 minus 7y squared over 2 plus 10y. So for my overall volume, it's a little delta y, so my limits have to be y limits. So y goes from 0 to 4. I've got my pi, and I've got this y to the 4th over 16 minus 7y squared over 2 plus 10y dy. So I take out the pi, and now I start taking the antiderivative. Y to the 4th becomes y to the 5th. I would have to put another 5 in the bottom. 5 times 16 is 80. We would get 7y to the 3rd. I'd have to divide by a 3, put another 3 in the bottom. 3 times 2 is 6. And then here, 10y squared over 2. So I get y to the 5th over 80 minus 7y to the 3rd over 6 plus 5y squared. So we get 4 to the 5th over 80 minus 7 times 4 to the 3rd over 6 plus 5 times 4 squared. And then when I plug in 0, 0 to the 5th over 80 is 0, 0 to the 3rd, 0 squared, those are all 0. So we get pi times 1024 over 80. 7 times 64 is 448 over 6. 5 times 16 is 80. If I divide by 16 here, we get 64 over 5. I can divide top and bottom here by 2. We get 224 over 3. So I'm going to have to change to a common denominator of 15. So times 3 times 5, and then times 15. So I get 192 over 15 minus 1120 over 15 plus 1200 over 15. And when all of that clears and we add those numerators and subtract, we get 272 over 15 And of course we can just stick the pi in the top. So these examples just show with the same region, we can rotate that region differently around different axes, and that affects how I set up my radii and the answer that we get.